Welcome to the lesson on magnetic declination. Let's have a look at the concept of true north and magnetic north as used in the context of magnetic declination. True north is the geographical north. It is the place where the Earth's axis passes through the North Pole. In our calculation of magnetic declination, it is important to remember that true north is stationary. Magnetic north, however, is the north to which a compass needle points. The compass needle in magnetic north aligns itself with the magnetic field of the Earth. Because the Earth's magnetic field changes from time to time, magnetic north also changes. True north and magnetic north, important to remember that true north is stationary, whereas magnetic north does change. So what exactly is magnetic declination? First important concept to understand is that magnetic declination is an angle. An angle is often the space or the gap between two lines. In our context, the gap or the space or the angle is formed by the true north arrow and the magnetic north arrow. So magnetic declination is the angle between true north and magnetic north. In our calculation on magnetic declination, we are required to find the size of that angle between true north and magnetic north. Our example reads as follows, that the mean magnetic declination 14 degrees 23 minutes west of true north, July 2012, mean annual change 1 minute westwards, July 2012 to June 2013. So let's try and make sense of the information that has been given to us. The information states that the mean magnetic declination is 14 degrees 23 minutes west of true north. That reading was taken in July of 2012. What it means here is that the angle between true north and magnetic north in 2012 was 14 degrees and 23 minutes. The magnetic declination in 2012 was 14 degrees 23 minutes. What, however, does west of true north mean? It simply means that the angle was on the western side of the true north arrow. So a mean magnetic declination to the west of true north simply means that the angle is formed to the left, or in this case to the west of true north. West of true north is also where the magnetic north arrow is pointing. The information further states that the mean annual change is 1 minute westwards, and that change occurred between 2012 and 2013. So what this means is that for every year that passes, the change in magnetic declination is going to be by 1 minute, and that change is going to be westwards. Important to understand and remember that magnetic north is not stationary. It does change as it aligns to the magnetic field of the Earth. According to our information, it says that for every year that passes, the magnetic declination is going to increase by 1 degree in a westerly or in a westwards direction. So it means for us that magnetic declination is going to move further westwards, but it's going to do so by 1 minute per year. So just a quick example, in 2012, if it was 14 degrees 23 minutes, then in 2013 it will be 14 degrees and 24 minutes. In 2014, 14 degrees 25 minutes, and so forth. So what this means is the following. To recap, In 2012, the size of the angle was 14 degrees and 23 minutes, and that angle was on the western side of the true north line. However, because magnetic north does change, it the angle became bigger by 1 degree, and we know that the angle becomes bigger because the information says that the magnetic north line is going to start moving westwards. So how exactly do we calculate magnetic declination? A typical question would read as follows: calculate the magnetic declination for the current year. The current year would be, in our case, at the time at which this video was recorded, 2025. The first thing that we need to establish is to find out how many years have in actual fact passed since the reading for magnetic declination was done. It is at this point that candidates often get confused as to which year or which date to use. Just remember that you're going to use the date that is immediately given after the information for magnetic declination. So in this example, the date immediately given after the magnetic declination is 2012. There's no need to use the month. We only need the year 2012. First step is to work out how many years have passed, and we call this the difference in years, and that is calculated by taking the current year, which is 2025, and subtracting the date on which, or the year on which magnetic declination was recorded. In this example, it is 2012, and we end up with an answer of 13 years. In other words, 13 years have passed since the magnetic declination was recorded in 2012. In the exam, it is at this point where you will be awarded your first mark for calculating the difference in years. The next important step in our calculation is to work out the total change. What this refers to is to try and determine by how much magnetic north has actually moved in relation to true north. Total change is calculated by taking the difference in years and multiplying it with the annual change. In our example, 13 years have passed since the magnetic declination was recorded. We also see that there's been a 1 minute 1 minute change or annual change, and of importance that this change has occurred westwards. Multiplying those two values, we end up with an answer of 13 minutes westwards. At this stage, it is very, very important that you do include the direction in which magnetic north is moving. Very often candidates lose the marks because the westwards is not specified. To make it easy for us in South Africa, all of our maps generally have a movement of westwards, and so therefore there is no reason for us to forget to include that word into our answer. Finally, we are able to then calculate magnetic declination for the year 2025, and that is done by taking the magnetic declination for 2012 and adding the total change to the reading for 2012. We use a plus or an addition here because magnetic north is moving westwards, or the annual change is westwards. This means that the angle between true north and magnetic north is getting larger. In other words, magnetic declination is increasing, and therefore we need to add these two quantities. In our example, the reading for 2012 was 14 degrees 23 minutes. The total change was 13 minutes westwards. When we add these two values, we end up with a magnetic declination of 14 degrees and 36 minutes west of true north. Again, an area where candidates often lose marks is the fact that the words west of true north are not included. What this simply means now is that the angle between true north and magnetic north is 14 degrees 36 minutes, and that angle is to the west of the true north arrow. Please pay attention to the way in which the information on magnetic declination is given on the map. The full uh, magnetic declination is 14 degrees 23 minutes west of true north. In other words, magnetic declination isn't just the values that are given, but it includes the west of true north. So in doing your calculation and arriving at the final answer, the words west of true north have to be included into your answer. Just at this stage, you will receive a mark if the degrees and the minutes are accurate. West of true north has been included, but you would also receive a mark for realizing that these values need to be added in this final step.